have time to review on Monday and then get the lab. So, we were talking about esterification, and it's a dehydration reaction. You lose water. Okay, so it's a dehydration reaction. You lose H and OH. What you're doing is you're getting rid of this OH here, this H here, and you're creating a bond. So I will show you more specifically, and you're making a bond. I'll show you on acetic acid. How many carbons are there in acetic acid? 2 carbons. So that's acetic acid. And then methanol is OHCH3. So for the esterification reaction between these two, a carboxylic acid and an acid, and I always draw the OHs pointing towards each other, especially in the beginning, because you'll see how they come together better. Let me put my CH3 here. So you get rid of OH here, H there, make a really long bond, but you end up with OCH3. That is an ester.
Crazy way I learned, because you were saying that people get esters and ethers mixed up. You know that O-E-O, the O-C-O.
Oh.
Stuck in my head. So every time I see that now, I have that going in.
Uh-huh. That's good. And the other product you get with this reaction is going to be water. That would be, now, I am not, if you have an esterification reaction, I'm not only interested in the main organic product, but if it helps you keep track of things, by all means, write water. And in lab, the esterification lab that we will do on Monday, we will build the carboxylic acid with the model. You'll build the alcohol with the model. And this will be covered on the lab exam. You need to show us how that ester forms. So when you see it with the models, it might help it cement more. The other thing with the models, you can see that little water molecule being generated. So that is helpful. So as long as you get that water molecule, you're going about it the right way to get your ester. So I'm going to get in the habit of, with esters, I'm going to square the group that's coming off the oxygen. That's your alkyl group. And I'm going to circle the parent. If you're a parent, think about this, or you observe other parents. Parents have a lot of responsibility, right? They have to make sure that this child gets brought up safely, all these different things. So if you want to think about esters for your nomenclature, the ester parent, the IUPAC parent, is the one that has the carbonyl, C double bond O, and that oxygen. So that is the parent. How you would name this is carbon 1, this is carbon 2, but esters are at the end, and I'm going to go through this in greater detail coming up. The way you would name this would be methyl, that is methyl, methyl, and then 2 carbon parents, ethane. What's the ending that you add for esters? Oat, yeah, O-A-T-E. Methyl ethanoate. You'll get them. And that esterification lab will help you tremendously because you will see it. Yeah.
That's the IUPAC.
That's the IUPAC way. The common way, what's the root for 2 carbons? Yes, acet. Good. Methyl acetate.
Think of it like you're an asset joining something.
Mm-hmm.
Some accounting thing.
I know, yeah. So here's another esterification reaction. Benzoic acid. What's the structure for benzoic acid? Good. So that's benzoic acid. And what does ethanol look like? Good. Excellent. I'm going to draw it in a more suggestive manner. So those OHs are close together. So they're pointing towards each other. So you're going to lose the OH off the carboxylic acid and the H off the alcohol. Now, I get a lot of students will say, well, can't you take the OH off the alcohol and the H off the carboxylic acid? You can do that. Coming up when we make amides, it's a lot easier if you already start from taking the OH from the carboxylic acid because you don't have an OH with amidation. So, Natalie.
Like acetate and formate, since that's like we write methanate or ethanate, if it even says acetic acid, would it matter if we wrote ethanate, methyl ethanate?
Oh, right, no.
Okay. So it has to be whatever it says.
Right, and you know, if you're asked, I think in the lab it says specifically like IUPAC. So just follow that. But for a quiz or an exam, I usually I accept either IUPAC or common. So. Okay, so you're gonna get rid of this OH, get rid of this H, get rid of the long bond, and then you end up with an ester, right? All right. So, who has the most responsibility? Right there. And this is one from your orange flashcards. Benzoate. Yes. So this is ethyl benzoate. Now, I'm not asking you to name these yet, but it never hurts to start getting you used to this. Because it really, truly is a foreign language when you're first coming across it. What is a benzoate? Now you know. But when you're frustrated and you're trying to learn this for the exam, you want to get a good grade, your grade depends on this. Yeah. So, these reactions, I want you to complete. Not every one of them is, you might have to flip some around, like this first one where the OHs aren't pointing towards each other. Now this last one, don't even worry about this. Esterification, we ask you to go forwards, we don't ask you to go backwards. So don't worry about it.
Cool with that.
So the first two.
That how the doctor something remember.
It always makes me nervous when a doctor says I hated organic chemistry.
They hate it because that's the class that's like the make or break your junior year for pre-med. That was mine. But the second one, you want to have a nervous breakdown. It's a whole nother way of thinking.
I took organic over the summer. That was insane.
So,
And it was all I did that summer was organic.
I had that with General Kim too, and that was enough.
So that's the Easter that you get, the ester. So just circling and squaring. Remember, the one that's circled is the parent. So this is benzoate. What's this alkyl group hanging around here? Yes, isopropyl.
Oh, just get it.
Yay! Isopropyl. So the name is isopropyl.
It's your favorite one.
Isopropyl benzoate. Mm-hmm. How would you circle and square that one? Yes, so far, the parents have been on the left. It's not always that way. So methyl propanoate. Good. So spelling, you kind of get used to the spelling after a while. And if you go back, in your note packet, it's like, oh, you just drop the E and then you add whatever ending. A lot of times, like, in the beginning, students will say methyl propoate or something, forget to put the propane. That's not a big deal. So now we're going to learn how to formally name esters. And hopefully it's not as intimidating, but I definitely remember learning esters, and it was hard. So, with IUPAC nomenclature, there are two parts to the ester name. There's the alkyl group, and that's the one that I always square or rectangle, whatever. And then I circle the parent. When I was a student, this is what I had to resort to doing, because at first it's so confusing. You can't. Which one's the alkyl? Which one's the parent? I couldn't get it. So that's why when I started squaring and circling. So how would you name that guy? Ethanoate. So methyl, ethanoate, good. And with esters, they're at the ends. So you don't need to put numbers where the esters are. So no number at the ends. Common, again, you're very restricted by your roots to form and a set. So a 1 carbon ester would be formate. 2 carbon would be acetate. Doing square, circle helps with common, even with common. So this would just be methyl, and it's a 2 carbon. So methyl acetate. Okay, so at the bottom of this page, I have 4 esters for you to name. They're not all the same way that we've seen. So be very careful when you're assigning your parents and the C double bond O and all that good stuff. So circle and square first before you get too caught up in naming it. So remember that the parent has the two oxygens, two children.
I did it backwards.
Now this methyl group here, I took off. It gets very confusing, so there's no methyl group right there. This gets squared. This gets circled. This one gets squared. This one gets squared. So if you got tripped up on those, make a copy of esters, a sheet in your pink notebook with esters. And for the first few times, just try and circle and square and see if you get it right, because that is the biggest challenge of esters. Once you realize what the parent is and what the alkyl group is, you're just putting these names together, which you've been doing this whole time in Unit 4, and in Unit 3 too. So it's just getting what's the parent, what's the alkyl group. So I hear a lot of people erasing. That is completely normal for esters. That's exactly how I was. I mean, what is going on? Why can't I get any of these right? Oh, so, and it's frustrating, but you'll get it.
I think the OCH kind of threw me off.
Oh, right, and then sometimes, yeah,
So I wanted to connect that whole.
right, like on these structures on the bottom. Yes. So once you have identified the parent and the alkyl group, like I said, naming is just easy. Well, easier than picking out the parent and the alkyl group. But on this one, the alkyl group is phenyl. So it's phenyl ethanoate. That's IUPAC. Common would be phenyl acetate. I always hated it when you're taking classes and the instructor makes it look so easy. Oh, she just squares and circles. And I say this again and again. Esters did not come easily to me, so it definitely requires. It took a lot of work. And if you put in the work, you'll have these in no time. But Lab 16 will help too, because there's a lot of practice nomenclature for esterification. Okay, this guy, IUPAC, is butyl methanoate. Common is butyl formate. Okay, so methyl, this is the one that I altered. I took that methyl group off because it makes it tricky to name. Methyl propanoate. And no common name, probably.
Can you tell us what that would have been called?
Oh, with the methyl group. Methyl 2-methylpropanoate. It's kind of confusing. We have a special nomenclature, like I mentioned before. We try to keep it simple. So
I won't see any of those on the test.
okay, 1, 2, 3, 4. Methyl. Methyl butanoate.
Is that the hardest one to say yes?
Esters and amides are probably comparable. But once you get esters, amides kind of fall in line with that. So we've learned how to name alcohols, thiols, ethers, aldehydes, ketones, carboxylic acids, and now esters. So we have 2 more left to name, amines and amines. Doesn't Unit 3 seem really easy now?
Oh, yeah.
Yeah.
I want to go back to that.
I know, yeah. Like, just give me a
Should
few.
split it to two.
Just give me a few Unit 3 structures. I'll be fine.
But this is the last we kind of see of this, right?
Yes,
Until
this is the
final.
last organic. And then we get back into Units 1 and 2 where we pull out the calculator and the periodic table and you're doing calculations and thinking about sig figs. And at that time, students say, we miss organic. But, you know, some students don't miss organic at all. Some do. It just depends on what you like. So, all right. Amines. Amines have a nitrogen. Single bond, there's no carbonyl anywhere. So amines, I always say, have a lot of different looks. This first one is an amine. The second one is an amine. And this third one is an amine. They're all amines. And we classify amines like alcohols. Primary, secondary, tertiary. So it's very similar to alcohols. Instead of looking at the carbon bearing the OH, you're looking at how many things are coming off that nitrogen. So one thing coming off this nitrogen means it's primary.
So it kind of acts like the carbon.
2 things coming off that nitrogen, it's secondary. 3 things coming off this nitrogen, it's tertiary.
So does it not oxidize but it reduces?
So not oxidized, it reduces. No, you can see oxidation reactions, but we don't do it. Tests. Okay, so for IUPAC nomenclature, I want you to cross this out. I think that's it. IUPAC goes back and forth with the way they name amines. We're going to stick with adding amine to the end, so we're going to have a suffix. So alkane, amine, not aminoalkane. The number is still needed. So you look at this IUPAC name, and what is she talking about? N-alkyl, N-alkyl. What is this? Oh, I'm so done with Unit 4. I can't wait to go to Unit 5. When we say N-alkyl, we're talking about the group that's attached to the nitrogen. So it could be a methyl group, it could be an ethyl group, it could be nothing if it's a primary amine. So we go up here, I'll name these for you, and maybe this IUPAC will make more sense. This first one, very simple, primary amine. It's just methanamine. You see how there aren't any other groups coming off that nitrogen? Methanamine. Now, this secondary amine, this is the parent, establish that as the parent. Since there's only one carbon, I don't have to put a number where the amine is, so it's going to be methanamine. But I haven't named that methyl group coming off the nitrogen. So it's going to be N-methylmethanamine. Weird. Amines are weird, aren't they? N-methylmethanamine. And this is all IUPAC. IUPAC. What's that? Right. So maybe, after working with this for a little bit, it will make more sense. Okay, so this tertiary. Okay, so IUPAC for this one. Methanamine, it's going to be your parent. I'll circle that one. And I'm going to square these other guys. Those are your ends. So you have methanamine. And it's going to be N-N dimethyl. Can't see my other. N-N dimethyl methanamine.
Is it
N, comma, N. Let me just N, comma, N. You want to go back to esters?
You can stay on that ester island alone.
You can stay on the ester island alone. I love it. Katie.
Why aren't you circling the ends for the parent?
Because the alkane is the parent, the amine is just, it is, you could circle if you wanted to. If it makes it easier, circle that. Maybe coming from esters, it makes more sense to keep it in there. So, and then maybe it makes it easier for you to square the other alkyl groups that are coming off. The parent with these amines is always going to be the longest continuous chain of carbons for IUPAC. So, going to this example, maybe seeing a primary, secondary, and tertiary amine, it makes more sense. So with a primary amine, you don't have any N-methyls. Secondary amine, you just have one N-alkyl, N-methyl in this case. A tertiary, you have two N-alkyls. So this example, is it primary, secondary, or tertiary? Secondary. So because it's secondary, you would expect to have one N-alkyl. So find your parent. How many carbons in your parent? 3. So my parent would be propanamine. But you have to tell me where that amine is. Oh, no. I'm sorry. Propanamine. I misspelled that. So it should get rid of that. Thank you. So what carbon is that coming off of? First. So amines, unlike esters, are not going to be at the ends. They could be in the middle. It could be at the end. So this is 1 propanamine, because this is carbon 1, 2, 3. And then coming off the nitrogen, I have N-methyl. So N-methyl 1 propanamine. Now you probably, what I find a lot of times is that students prefer the common nomenclature with amines. Let me show you common. It's just the alkyl groups. Just cover up the nitrogen. What are the alkyl groups? Methyl and propyl. So methyl, propyl, amine.
You said that you can write it either way. And I feel like you're not going to specify what are
Right. Right. I could give you a common name and ask you to draw that. So be familiar with what the common names So this first structure up here would just be methylamine. The second one would be dimethylamine. And the third one would be trimethylamine. Okay, so
It's gonna be fun recall in the final.
it's surprising how much you remember, because we're not that far away from the final. So, shocking, that is.
And there's how many questions per section?
15. So Unit 3 will seem really, like if you go back and look at the final review for Unit 3, oh my gosh, yeah, it's so easy then, like. So, but Unit 3 and Unit 4 students do well in the final. It's not. Okay, so these that I have underneath. What is this structure from your orange flashcards? Benzene with an H2 on it. Aniline. So the parent is aniline. So this is what's NO2 called? Amino or nitro? Nitro. 4-nitro aniline. And the common would just be para nitro aniline. Okay, this first one, which do you want to do first? Common or IUPAC? IUPAC, okay. Longest continuous chain of carbons? 2. So, ethanamine? No. If you put one ethanamine, I would not count off, but you don't need it because there are only 2 carbons where it could be going to be put on the first carbon. But, at this point, if you get ethanamine and you put one, wouldn't count off. What else do I need to name in this? N-methyl ethanamine. Common, ethyl. See, you're starting to like common. You're starting. I could see it. She said it so quickly. I got you. Ethyl, methyl, amine.
I like that one. It's cute.
Oh, yeah, a lot of funny names.
Yeah.
Yes. Ethyl, yeah. Oh no, what did I do to you guys right here? Oh, yes.
Is that a aldehyde at the end?
Oh, yeah, that's an aldehyde.
An aldehyde and amine.
An aldehyde and an amine. What do you do here?
So just the
Run, hide. Yeah.
no reaction.
No reaction.
Can't do it.
Not
You don't
possible.
want to do it.
Yes, that's right.
Go to algebra, no solution.
Yeah. Does the aldehyde get?
Aldehyde is more important than that amine.
Is it because of the double bond?
It's because of the double bond, because of that carbonyl. So, poor amine. So, you go back to Unit 3. Amino.
Oh my goodness.
And there's no common name for this one. So it's going to be 2-amino propanol
Because that'll be on the
Otherwise,
exam.
you'd be asleep.
Because that was the, oh, okay, that's why we.
Mhm.
So anything with a carbonyl group in it gets preference over whatever else is there.
Right, so when you have a carbonyl with OH, SH, in H2, this becomes hydroxy, this becomes mercapto, and this becomes amino.
How come the amino wasn't listed over? Is that something different?
No, I should have included it too. Mhm. So anytime you have a carbonyl, yeah. So back in on page 11, you could add an H2 as well. That's amino. And then on page 12, thank you. On page 12, add Alright.
And then see why you said this working on this one.
Well, you start with what?
I can see why. This is equivalent to the anatomy and nerve test of this class.
Yeah. And I think once you get the attitude that Unit 4 is horrible and it just, you can't give in to that, even though you want to. And I know as a student in certain classes, I would get there too. Like, oh, I'm never going to get through this. And I think we're at a tough point in the semester because we're not at the beginning where it's all fresh and new, and we're not at the end where, you're thinking about the holidays, or, if you're in spring, you're thinking about summer. We're just kind of in between. You can't see the way out yet. Yes, you're just stuck. And you're stuck in Unit 4 of all units to be stuck in. It's like a
On Esther
nightmare.
Island, where she wants to stay.
Then we'd have no students.
No,
I don't know. Conversion problems to start with are pretty bad too. So.
So that has one ester.
Now, is it an ester?
No. Because
So it's carboxylic acid.
Uh,
Ew. No. Did not just do that. 1, 2, 3, 4, 5, 6, 7. So what's the ending for carboxylic acids? Heptanoic acid. Good. Do I need a number? No. And then on 1, 2, 3, the beta carbon is an amino group. But we don't put beta in the name. Just use it as a reference point. So this is the 3 amino heptanoic. And this is alpha, and that's beta, and that would be gamma.
So you're throwing this
Your
in there.
carbon is connected to your OH. That's your starting point. And you bump down to the next one. That's your alpha. And the next one's your beta. And the next one's your
Are you
beta.
gonna have to do that? Okay.
Mm-hmm.
I remember she showed us that true or false question.
Mm-hmm.
Is that how it will be on the test, or?
Hey, at least we don't have to write all the little numbers like we did in the, radiology part of it or whatever.
Now, before you guys get too upset with me, you might get really upset with me with this structure. Who can tell me what that is?
Is it like phenol?
Think about your orange flashcards.
Oh,
Aniline.
Aniline.
Yes. So this is aniline.
It's not in H2.
It doesn't have to be. Aniline can be a primary. Primary would just be aniline, nothing else. But you can have a secondary aniline. You can have a tertiary aniline. So amines have many different looks. You know those celebrities who, are actors who can change, they wear a baseball hat,
Joan Rivers plastic surgery.
right, yeah, or they portray this type of character in one movie and then completely different in another movie. That's how amines are. So this is aniline. So the IUPAC would be aniline, N-ethyl aniline. Common. This is where I'm going to sell you on common.
try.
Cover up that NH. What are your alkyl groups? Ethyl and phenyl. Ethyl, phenyl, amine.
You said just go with the NH.
All right, this last one, and I didn't have the diamine. Just like our other diol, dioic acid, dial. A diamine, 2 amines present, 2 NH2s present. So it's going to be number, comma, number, alkane, diamine. So now, this last one, it's propane, diamine, propane, diamine, and how would you number that? 1, 3. So we have one more functional group left to name, amides. So we'll learn that next. And we have one more reaction to work with, that's amidation. So not that much more.